In this video, I would like to talk a bit about the basics of video compression. Many times when talking to clients or suppliers, I see that they don't have a full understanding of the video compression pipeline. Is to say, why is it needed? How it is done, what implications does it have, what is the difference between a format and a codec, what hardware is needed, is it optional, the having a GPU, or is not optional up today, actually. Well, I want to talk a bit about these things. I will not be talking about any of our products today because I think they are not important for these basic concepts that I think are absolutely crucial to understand and to manage, so that you can understand what exactly you are proposing to your client and why you are proposing it to your client, even though the client may think that that is not necessary, or maybe it is. Let's look at it. The first thing I want you to understand is the problem that we have to resolve. We are thinking actually of videos of 4K easily. 2K always is the minimum, which was not the case a few years ago. Now we talk about 8Ks at 60 frames per second. 8Ks at 60 frames per second, it means 60 images each second of 8K resolution. This is a quantity of amount of information that is massive. Is to say, it's impossible, absolutely impossible, to be sent without compression through a network, and the volume that it would need in a hard drive to be stored is immense. We don't have the idea, we don't have a clear idea of how big is a 4K video, is an 8K video. It's 4 times the size of a 4K and 60 times the size of a 2K. It's exponential, right? The growth of the space that we need. So the idea is that what it is encoded, we will see exactly what it means. The size is magically reduced, right? And at the end, an encoded video is a video that represents an 8K video, but using less space in the hard drive and using less bandwidth in the network to be transmitted, right? This is not magic, this is compression, right? You take the original information and you compress it using mathematical methods that may have different characteristics, one or the other. There are different ways of compressing video and the result is that you have a manageable file that can be transmitted or can be stored without so much effort, right? So the idea is that you capture the video using a camera. The camera sensor is not compressed. It's a full image without compression per frame. So we have 60 times 60 pictures per second. It goes through a process that is the encoding process, that it is the compression phase. Here we encode it using an encoder. We will talk about these encoders in a few minutes. Then we place it in a container to be able to move it from one place to the other. This is where formats come into place. So we can here introduce the idea that the format is one thing, and the compressor, the encoding, the codec is another different thing. And when it is in a container, it can be stored in a hard drive, sent through the network, etc. When it arrives to the destination device that has to present it to an LED display, to a video monitor, it has to be demaxed, is to say it has to be taken out of the container and packaged and decoded. Apply the mathematical algorithm to recover the original pictures that are going to be displayed in the monitor. 60 pictures per second, okay? This is the objective. And at the end, the rendering process, which is done by the device, it presents these 60 images per second in the display. So you end up having a thing that may be very similar to what is captured. Why do I say very similar? Because there are different ways to encode, to compress the information. Some can lose information and others can be lossless, is to say nothing is lost. Each one has its advantages, are different tools, okay? So the first thing that we have to understand here is that one thing is the container, the format of the file that handles all the video, right? Imagine it like a box. If the box is slippery, for example, would be very easy to move, but if it is not slippery, would be very easy to handle. Each format has advantages and disadvantages, right? So you have to choose the right one for what you are going to use the video. And inside that box, you place the content, okay? So the codec is the algorithm that compresses the information and has no relation with the format. Imagine like a box and the content that goes inside the box. Inside that box can go audio, video, etc., right? You may use one format for different codecs, okay? So MP4 is a format, H.264 is a codec, right? This codec, this algorithm, can be implemented by software or by hardware. We will talk it in a few minutes, okay? The importance of this implementation will be clear when we talk about performance, right? So, format, codec, different things, okay? If you want to compress more or less the information that you are going to transmit, in this case the video, you would have to select a different codec. So, Windows Media Player architecture, is to say a player program, taking as an example the Windows Media Player, has an architecture that is capable of using different codecs and taking advantage of the different hardware that you may have. We have the application layer, which is the part of the program that simply displays the information, right? In this case, the video, the image that you see when you look at the monitor, but inside what you have is an operating system architecture that allows you to open the different formats and use the codecs that you have installed in your system to understand the information that is inside that box, right? That is inside the format. Each codec, depending on the hardware that you have and the type of codec that you are using, will select different physical resources of your computer to decode these images. For example, if you have a CPU and your computer does not have a graphics card and a specialized GPU, it will try to decode, to uncompress the video using the CPU. On the other hand, if you have a GPU, we'll try to use the GPU first because it's much faster and it's much more efficient to decompress video using the specialized hardware. It seems that it's just a matter of cost. It will be harder or not harder for the computer, but it goes beyond that when you go to high resolutions like 8K. Okay, so but the idea here is that everything is organized by layers. You can change or introduce different codecs in your player without touching the applications, right? And this implies that you may add new codecs, new formats for your computer to understand different new videos. Okay, so we can see here that the problem of the decoding will grow. At the same time, the resolution of the file also grows. Why? Because it will have to manage much more information. If we want to use the CPU is a very good tool for performing some kind of operations, but not for others. Is to say, if you are going to try to process 60 frames per second at an 8K resolution, the CPU will not be able to do it on time. So it will be losing frames. As I have not been able to arrive to decode this frame, I go to the next one without ending the first. So this will provoke jumps in the video, right? Some frame losses. Some of them will not be noticeable by the one who's seeing the video. Is to say, if you are watching a film, probably you will not realize that the CPU have jumped 5 frames. But if you are looking at an element that is moving pixel to pixel from left to right and the system is missing frames, you will see it clearly in the monitor. Just one single frame, you will see it. This is why it's so difficult to decode a video that is moving horizontally. It's important to choose the correct codec for that video. Another problem is that it will make the computer go so slow because the CPU will be completely used to decode video and not to perform other operations that the computer needs. So if the CPU cannot do it, how can we do it? Here is where GPUs comes to play. The GPU is a part of the graphic card that is specialized to decode video in different formats. Okay. Another advantage is that the memory of the graphics card is much faster than the memory of the computer, so it will be much more efficient. in 8K videos with 60 FPS resolution, with 60 FPS, it's supposed that you are not going to miss any frame, and your CPU will be completely free, so the system will be much more efficient. Okay. So here the important message: if you think that your configuration may have to run 8K videos, having a graphical specialized card is not an option, is mandatory. Okay, otherwise maybe it cannot do it, right? So how have codecs been evolved and why? The idea is that codecs have been evolved during time because of the growth of the resolution. As the resolution has been gone up, the formats, the files of the videos has been also grown, and the market has needed better algorithm to compress the information. But better compression means more computational requirement. So this is why you have different compression systems, different compression codecs, and at the same time they need new hardware to perform correctly in the reproduction. Here I want to note one special element, that is Apple ProRes. Apple ProRes is a format that has no compression and does use only the CPU. So it's a format that can provide so much quality because you are sending the video picture by picture, frame by frame, without compression, but on the other hand, it has a computational complexity. It means it requires an effort from the CPU that is brutal, right? It's the worst codec for production. What is it good for? It is very good at the phase of creating the video, managing the video, and generating the final format. It's a development tool. It's a fantastic development tool, but it's not recommended at all to be used in production, even though you can do it, right? You can do it, but you will have higher risks depending on the computer you have, the videos you're using, right? So here is an important comment, because I've been asked many times for clients about using ProRes, and no, ProRes is not for delivery. Is a working format, a working tool, right? So, having said that, we have to see the cost of the compression and the limitations and the implications that we have. Is to say, as we need more compression efficiency, we have to go to better codecs, and as we go to better codecs, we need more computational power. Generally, it means that you need a more efficient computer, which means a newer graphic card, right? So take a look here at the compression efficiency of Apple ProRes. Does not have any efficiency in compression and needs so much computational power, because it's a tool for development, for creating videos, not for playing videos. Okay, even though in some cases it may be the unique solution for playing some kind of non-standard files, but we will not talk about this in this video. So the key concept here is that modern hardware is a strict physical requirement. The client would not be able to tell you that they don't want a graphic card. If they want to play video, they must have a graphic card. Otherwise, the next message that you will receive is, hey man, the computer you send me is not running the videos smoothly, it's had some jumps. Is to say, it is missing frames, okay? So, to have an idea what kind of codecs we have the 264, typically an MP4 file, right? We talk about an MP4 and we assume that the codec is the 264, but it's not mandatory, it's an option, right? But this combination is a standard. It goes to 4K fantastically well. It has native support in Windows 11, and it's decoded by hardware, right? It's the universal playback mode. It can go up to 4K, okay? But for going to 4K, the best codec is the 265, which is an evolution, typically packed also inside an MP4 format, but it has no native Windows 11 support because it has to be, some royalties have to be paid for licensing. So it needs an NVDEC or a VCN chipset, which means specialized system. If you try to run it in a bit older computer, this will have to be decoded by the CPU, not the GPU, because you will not have this modern hardware, so it will give you problems. So H265 is a very good option for 4K, but you need the hardware, the specialized hardware, and to pay for the Windows 11 support. I think it's $1 in the Windows Store. It's worth it, but you have to know that you have to do it. Next evolution is AB1 and VP9. VP9 for web, it goes very well. Most modern GPUs run it, like it's used in example in YouTube. AB1 goes to 8K and high efficiency. It's a highly efficient format. It requires, of course, a specialized hardware. It requires a store extension, and it's typically packed in a WebM or MKV format. Note, Apple ProRes. The typical container is a MOV file, does not have any support in Windows, and it uses the CPU, right? It's software decoded. It's for professional editing, not for delivery, okay? So, if you want to build a computer to run video, the things that you have to have in mind is that you need a GPU, right? A modern GPU. You will need a hard drive that is fast, right? A modern NVMe slot used in a drive that I used to recommend 1 GB, but well, the size is another matter. You need at least 32 GB of RAM, right? For the case that you have to decode videos on the CPU. The CPU should have to be an i7, i9, an Intel i7, i9. The display bandwidth must be HDMI 2.0 or a DisplayPort 2.1, and as minimum. And the more memory that the graphics card has, the better it will perform, right? It's if you go to 8K, the computer is important. If you are in the 2K video files, which is the case for many LED displays, you can go to a not so evolved computer, a much cheaper computer, right? Here you have the key point for a high resolution reproduction system, right? So, things to have in mind when you choose a graphics card. I recommend you to go to a NVIDIA card because they have very good drivers, but I cannot give any bad recommendation about AMD or Intel. I always use NVIDIA, recommend NVIDIA because it's a safe bet, but you may use other brands. But what is important is that you have at least 12 gigabytes of VRAM, right? This is the memory that is inside the GPU and the memory that will allow you to move image information faster, right? These 2 points are important. For eliminating system bottlenecks, I mean, what if you have a great GPU, but you have a slow hard drive problems? You will have a bottleneck there. Choose a solid-state drive, use DDR5 memory if you can, and the HDMI and the or DisplayPort should be the modern ones. Trying to use an older HDMI to play 8K, it ended up being impossible because previous HDMI versions are not able to send so much information per second as needed in a 4K reproduction. So, Windows 11 configuration checklist. Be sure that you have the right codec installed. If it's not installed correctly, you will see the image in black. Go to the Microsoft Store to get the latest codecs that are not royalty free. In this case, the 265 and the AV1 video extension. I think the last one is free. And then when you have done this, you will have your hardware unlocked. Is to say, then the codecs will be able to send the information to the GPU correctly. Okay, otherwise the GPU will not be used unless you have the right codec. Okay, so here you have a fast summary what codec format and what hardware you should use depending on the resolution that you may need. And this is all for this video. I hope this video has been useful. I hope that the ideas are clear about video reproduction. In the next video or one of the next videos, I will talk about sending video through the network and what other components do we have to have in mind to send video through the network. For example, to reproduce one element in n different screens, how it is done, how it is managed, pieces, etc. And if you have any doubt or any comment, please do not hesitate to contact us. And I hope you have a great week. Goodbye. Thank you.